Okay, so in this video we will be solving equations using properties of equality and combining like terms. By the end of the lesson, you'll be able to solve for a given variable using properties of equality to create equivalent equations. You will also recognize when you need to combine like terms while you're solving these equations. Let's get started. So, based on the objective, you might already be able to answer this question. How did these look different? How did these equations look different from the ones we saw in class today? Hopefully, you're noticing that there are two x terms on this equation, and they are on the same side. The first step to solving is making sure that I only see the variable appear once. In this case, I can combine these two like terms. I have a 1x and a 1x. When I combine, I end up with 2x. So now this would state 22 is equivalent to 2x plus 2. Just like in class, we want to make sure we can isolate this variable. We're going to use properties of equality. The piece that is the least attached to x is willing to move over first. This 2 is a coefficient to x. It will be saved for last. This 2 over here is a little less attached. So I can use the subtraction property of equality, or I can even refer to it as the addition property of equality, technically adding a negative 2. But as long as I add or subtract the same value from both sides, my equation will remain equal. I have a new equivalent equation, 20 is equal to 2x. We still want to isolate this x. To isolate x, I must divide or use the division property of equality to get 1x on one side and 10. So 10 is x. Let's take a look at number 2. Number 2 has the same difference compared to the equations we saw today in class. This negative 1y and this negative 1y must be combined. I cannot isolate y unless I only see it once. So my 7 remains. Negative 1 minus 1 more, or same sign add, is negative 2y, and that's equal to negative 1. Now our goal is to isolate this y, since it's the only y that appears in the equation. I must move the least attached first. Using the subtraction property of equality, I can subtract 7 from both sides. I now have negative 2y is still here. These combine to 0, and that's equal to same sign add, negative 8. I'm still interested in isolating this y. To do so, I must use the division property of equality and divide by negative 2, divide by negative 2. We now have y equals positive 4. We can also check these solutions like we did in class with lesson 8. If I rewrite the original, 7 minus y equals negative 1, if I want to show a check, I need to be sure that I substitute 4 everywhere I see a y. So I would have 7 minus, and then here I would have 4. And then I'm supposed to subtract y again, so subtract 4. And then we want to check if the left side is equivalent to negative 1. 7 minus 4 is 3. 3 minus 4, different sign subtract, we get negative 1. So our solution is correct. The main difference in today's video lesson compared to today's lesson in class is that before isolating the variable, we want to check if we can combine like terms first. It's important to note that you can only combine like terms when like terms are on the same side, meaning the same side of the equal sign. Equal sign. or the same side of the wall, for those of us that like to draw our wall. Okay, let's take a look at number 3. I see n and 6n on the same side of the wall. 1n plus 6n is now 7n minus 9 is equivalent to 30. Our goal now is to isolate this n. I can use the addition property of equality by adding 9 to both sides. My new equation, which is still equivalent to the one above, is 7n is equivalent to 39. I now must divide by 7. Okay, our goal, again, is to isolate the variable. When dividing by 7, I realize that 7 does not divide evenly into 39, so I'm going to choose to leave this solution in fraction form. Let's try one more together. This one looks a little bit more complicated, but in reality, it's the same. I have this negative x and a positive 2x. Different signs subtract, so negative 1 and 2. If I have to subtract, I get 1. It's going to be a positive 1 because this term is larger. So we have 1x, and now we must combine 7 with 2 to get 9. So 1x plus 9 is equal to 4. To isolate the x, the 9 is the least attached. Let's use the subtraction property of equality. Subtract 9 from both sides. I now have 1x is equal, different signs subtract and get 5, but it's negative 5 because the 9 was larger. I now have my solution. Now would be a great time to pause the video, try the problem on your own, and then press play to check. Okay, so now check your work to problems 5 and 6. Notice on number 5, we do have a fractional answer. You can reduce 40 and 14 by dividing each by 2 to get this reduced form, but 7 does not divide evenly into 20, so we can stop there. For number 6, your answer should be positive 19. Over here, we should have negative 19 divided by that negative 1 coefficient, which negative divided by a negative is always positive. If you have any questions, remember to stop in for extra help or have some questions prepared for tomorrow in class. We can begin class by going over any of your questions from the video. Okay, so by the end, we were able to recognize when we should combine like terms, and we were using our properties of equality as we solved. Thank you.